Hi, good morning, folks. I know it's really early in the morning. I really appreciate joining us here for AutoML session. This is about AutoML, which is part of Azure Machine Learning Service. My name is Krishna Anumalasetti. I'm a program manager in Azure Machine Learning team. I've been in the team since when we first conceptualized AutoML, roughly about 18 months or so ago. And I have a couple of my colleagues that are going to be joining me with here, co-presenting this session, Eric and Francesca. And we also have Dean from one of our customers. So what are we going to cover in this session today? Eric will start what a basic machine learning workflow looks like, a typical one. And then why do you need AutoML? There are many, many machine learning tools out there. How does AutoML will benefit you, right? And how does Azure AutoML works? Then Francesca will actually walk you through with a real use case and how you can use AutoML to build a real machine learning model. Right? Dean from Walgreen-Boots, one of our customers, will share his experience of using AutoML and how he was able to do things that he could not without the AutoML. Right? And then I'll close off with some of the integrations that we're working with, where AutoML is powering some of the products that, in turn, provide AI offerings for their users. Right? So what do you expect to get out of this session? If you have not done any machine learning before, you will be able to build your first machine learning model in just a few hours. If you're a seasoned data scientist or machine learning practitioner, by the way, how many of you here are seasoned data scientists or machine learning practitioners? OK, very small number of people. You will be able to find that AutoML will eliminate some of the tedious and manual tasks and help you build models faster. So without further ado, I invite Eric to.
Thanks, Krishna. All right, so let's talk about a traditional machine learning workflow. There's basically 4 quadrants here. If you want to start thinking about how to use machine learning in your application, the first thing that you're going to do is you're going to be sitting in a conference room, and you're going to be talking with a product manager or the product owner. You're probably going to be talking with a developer as well, and you're going to figure out there how machine learning can help your application. FYI, AutoML does not help you at this stage. We cannot replace this. This is just something that you're going to have to do and think very carefully about. Once you've decided how machine learning can be used in your application, first, the data scientist is going to have to think very carefully about their data. I spend a lot of time at this stage talking to engineers, figuring out what this column means, if it's based on an event, how this event was emitted, when it was emitted, all the details of the data. After I figure out what these things mean, then you need to be even more careful and do analysis on how frequency these data or these events are emitted, understanding what kind of outliers, et cetera, et cetera. So the data understanding stage is a really, really important part. And AutoML doesn't help you at this stage either. This is where your domain expertise is very important. Where AutoML begins to help you is the bread and butter machine learning stage here, which is after you've decided what data you want to use in your machine learning model to help your application, then you need to figure out how to transform this data into a format that your machine learning model can ingest. This is a super important part. After you've done that, you need to think carefully about what models you want to select, the details of the parameters of the models, and then train them and see if they can successfully train. And then finally, you need to figure out, OK, I have some trained models. Are they good? You need to evaluate them through a variety of methods. So this is a very time-consuming part. And frequently, you're not just going to go through these steps sequentially. After you do all this, you're going to go back to the business understanding stage and talk to the product manager and the developer. And you're going to probably have to iterate again several times. Finally, after you've done this, within the traditional machine learning workflow, you're going to finally enter the deployment phase. And here again, Azure ML and AutoML work very well together to help you do this really easily. So these are the 4 stages. Let me now walk you through a concrete example. And this is something that I have done at a previous job at an e-commerce company, where the particular part of the product that we want to improve is selling a particular item on a website, let's say. And as a product manager, what you want to do to analyze how well you're selling this product is you want to analyze your funnel. So your sales funnel will involve, imagine you have like 100 people coming into your app and selecting a make and model of a Surface Book, let's say. These people are going to progress through a variety of screens before they finally click buy, and it's going to gradually funnel down until some smallish fraction of people click that. Now, you might analyze this funnel and decide there's a particular part of the funnel where you have a bottleneck. So you might have a lot of people that are getting stuck on screen size. I select this, by the way, because when my family members talk to me about computers to buy, frequently they really get stuck at the size of the computer. So you might think, well, maybe machine learning can help here by personalizing the selection here. You might say, well, maybe we can default select one of these options based on what we know about the user. Okay, so this is the kind of thing that you're talking about in the room with a product manager and a developer to see where machine learning can help. And once you've decided, okay, let's personalize things, you need to put this idea into a very particular form that fits with machine learning. You need to decide, is this a classification problem? Are we just going to select one button or the other? Is it a regression problem? Maybe you have many screen sizes and you want to just predict screen size. Or are we going to treat this as a time series forecasting solution? Are we going to try to predict the future based on the past? By the way, AutoML supports all 3 of these tasks. Right now, let's just talk about classification, because clearly this is just a binary classification problem. So after you've met with the product manager and developer and you've decided that we need to personalize these selections, the next thing as a data scientist is you need to start understanding the data. So right now, I'm just showing you 3 rows of data. If you're using AutoML, you should probably have a lot more data than that. So let's imagine in reality you have 10,000 or 10 million rows. But for now, we just have 3 rows. And this is a really common pattern in machine learning where you're actually joining user information onto item information. And you're going to try to predict something. In this case, the target variable is what screen size. So at this point, you've theorized that the user device information will correlate with the target variable of what item they selected. You're going to theorize that maybe the user age and the location correlates with it. And also, you might have some free text in your application. So free text, which here I'm calling it last message, so you can imagine maybe there's a messaging layer of your app. This could also be like a search query. It could also be item information. But frequently, you have free text in your app. And finally, you have a timestamp. So this is all past purchases, and everything has a timestamp. So at this point, you have many different options to featureize your data so that your data can be ingested into a machine learning model. With a numerical feature like user age, you will inevitably have missing information. Like if the user is logged in, you'll have it. And if the user is not logged in, you won't have it. With these ages, with these numerical features, you can decide to discretize these features. If you have many features, numerical features, you might decide to cluster them. You have many different options. Now, that's only for the user age here. You also have a bunch of categorical variables. What do you do with these categorical variables? Again, you have many different options where you can do one-hot encoding, target encoding, and you can do specific things for specific learners as well. Now comes to my favorite part, and these are text features. This is what I've been working on in the AutoML team for the last little while. You have even more options with text. Okay? I mean, this is a whole branch of machine learning called natural language processing. And what you could do to featureize on your text is you can treat it at a word level. You can treat it at a character level. So word level would be like word n-grams. Character level would be character n-grams. Or you can begin to do kind of more latest and greatest techniques around word embeddings that are either trained on your data set or pre-trained on larger corpuses. So there's a lot of options for text that you have. Finally, with time features, let me call out what we do with time forecasting. This is not a time forecasting problem, But Francesca, who's coming up next, will walk you through what time series forecasting looks like. We have lagged features. So if we're trying to predict something tomorrow, we might want to know what happened yesterday and the day before that should go into that prediction. And we have frequency detection, like how often what your data cadence is. And finally, no matter what, whether it's classification, regression, or time series forecasting, we also have timestamp features. Namely, if it's a holiday, you might have a different opinion about whether you want a 13.5-inch or a 15-inch computer, for example. So we have a bunch of different possibilities. And the point here is that without automated machine learning, this begins to start looking like a combinatorial explosion of different possibilities that you need to work across. And with AutoML, the point is that we make this easy. We have a smart way of searching across these different options. And the really cool thing is, right now, you might have two data sets with all these same columns, but we might featureize them in different ways depending on your data set. So how we featureize your data set is optimized for your data set specifically. So that was the feature engineering part. The next thing we need to do is think about what learner do we want, what machine learning algorithm, and what set of parameters should we select so that we can optimally separate the users who tend to select 13.5-inch computers from the users who select 15-inch computers. And here we have a huge combinatorial explosion. Just for XGBoost, if you select a few reasonable parameters for all the different free parameters in XGBoost, you can quickly get into billions of different parameter configurations to search across. And so oftentimes you're just going to fall back to random search, which is not as good as it could be. So without AutoML, you might do random search here. But with AutoML, we have kind of a smart search strategy. And this is something that Dean will be talking about from Walgreens-Boots regarding how they leverage automated machine learning. So automated machine learning to select not just the right parameters for XGBoost, but also the right parameters for many other different machine learning algorithms. So it selects both the machine learning algorithm and its parameters. We basically use AI to build AI here. And we treat this kind of like a movie recommendation problem. So a movie recommendation will often take the form of viewers like you watch Avengers Endgame. And the idea is, based on a movie app's past data, they've seen a bunch of users who have viewer histories similar to yours, and they notice these other viewers tend to watch Avengers Endgame, so they recommend it to you. So this is just the Hello World collaborative filtering personalization here. What we do is we slightly change this around to say data sets like yours perform well with this particular machine learning algorithm and set of parameters. Okay? So the whole point is we've seen a bunch of data sets before and how well a bunch of machine learning algorithms and their parameters perform on them. So we are smart in recommending to you a good machine learning algorithm and its parameters. And the idea is as we give you a machine learning algorithm and parameters to your data set, and we see how your data set performs, the next recommendation will be even better. Just like in a movie app, as you start watching more and more, I don't know, superhero movies, as you might imagine, your recommendations might become more targeted. So this is based on a Microsoft research paper called Probabilistic Matrix Factorization for Automated Machine Learning, mouthful, that you can read in your spare time. In this machine learning recommendation process, we maintain privacy. So AutoML, we do not look at your data at all. All we see is like the accuracy that your data set has for this particular machine learning algorithm and other metadata like number of columns, for example. So absolute privacy, you have control over your compute and your data. So let's bring this back to the sales optimization problem, our example. So AutoML is not replacing how you understand your product. So in this room with this product manager and developer, you are going to have to figure out whether you want to auto-select these options and maybe even tell users whether, tell them that, hey, this is a recommendation. Users like you like this. Or maybe you want to rank these things. You're going to have a bunch of different options, and obviously we can't replace that. But we are freeing you up to spend time thinking very carefully about how to use ML in your application. And we're also not telling you what training data to use, because again, that's something that only you can do, and you should think very carefully about. But what we do is once you've defined how you want to use machine learning in your application and what training data might work to solve this problem, we'll give you a very good set of features and a very good model to form a whole machine learning pipeline, which is very performant. And I should note, in my past experience, frequently I'm iterating multiple times. For example, in the data, we have zip code here. Very frequently, I'll already have a whole model trained, which is really, really good. I'll come back, and the developer will tell me at inference time or prediction time, we don't have zip code. We only have latitude and longitude. So these kinds of iterations are made possible with AutoML because you don't need to rewrite your featurization pipeline if your data changes, and you don't need to re-optimize your models. AutoML can do that for you very quickly and give you an excellent pipeline. So finally, after you go through all this iteration, the next big story is deployment. And this is something that has me really excited. So we have a number of different, Azure ML has a number of different deployment options which work very nicely with AutoML. Obviously, if you have a trained model, you can deploy it as a microservice. You can deploy your trained model on an IoT device. And the thing that really has me excited is Onyx. So at my previous company, we would train models frequently in Python, but we would have a Java service, or we'd be putting models directly in other people's services in our company who were mostly Java services. So we had to figure out how to take a Python model and put it into a Java runtime. And there were 6 data scientists, and we had like 6 different ways to do it. I wrote a custom pipeline, in my case, for one particular featurization and model, and I kind of restricted myself to that in the future, only because I didn't want to rewrite that pipeline. So Onyx solves that problem. You can have a AutoML trained model, and you can put it into a C# or Java runtime, for example. So deployment can be really easy, and this can be very useful if there are many cases where you might not want to stand up a microservice. Maybe you need an air-gapped solution, or you just don't want to have the latency overhead or just the extra moving parts of a microservice to worry about. And Onyx can do that for you. And I should note, if you want to learn more about Onyx, there will be a session today at 12:30 p.m. So please attend. So that about sums up my part. Thank you very much, and welcome, Francesca.
Thank you. Hi, everyone. I'm Francesca. I'm a data scientist at Microsoft. And in the past few years, I have been working with many Microsoft external customers to build, train, test, and deploy the hand-to-hand machine learning solution on Azure. Specifically, I have been working with many customers who operate in the energy industry. And I have been working for them building an energy demand forecasting solution, where again, the goal is really to predict the future load, the future energy consumption on an energy grid. So as you can imagine, this is a very critical business operation for many energy companies because they always look to ways to forecast the future load so that they can balance supplies and demand. So for this specific demo, I'm going to use a public data set that is from the GEFCOM 2014 forecasting competition, and it consists of 3 years of hourly electricity load for the New York State area. And as you can imagine, load is also very highly dependent on temperature. So including external data like weather, location with coordinates, oil prices, and special events such as holidays, it's very, very important. And data scientists like me are always looking for external data. And so we were able, for this specific use case, to use weather data from the Azure Open Dataset. Let me show you. Actually, as a data scientist, I love Azure Open Dataset. This is a collection of data sets from the public domain that accelerate the development of machine learning solution on Azure. Here you can search for your data set. For this specific use case, we use the NOAA Global Forecast System. Let me show you. You can just click on this. You'll get an overview of the data set. You can see all the columns with the different information. And most importantly, as a data scientist, you can get information on how you can get access to to the data. Here, exactly, there is the sample code that I use to integrate my original energy data set with this weather data, because of course, I want to see if this can help me with improving my models eventually. So let me show you. This is my machine learning workspace. As a data scientist, I always start from here. The Workspace is a top-level resource for Azure Machine Learning service. It's a centralized place where I can see all the artifacts that I'm going to create when I'm going to use Azure Machine Learning service. Let me show you. For example, you have the experiments. That is a grouping of different scripts from different runs from a script. Then you have pipelines, compute, models, image deployments. And as you can see, one option here is get started in Azure Notebooks. So if you want to start building your experiments, running your code, you can just click on this, and you're going to be directed to Azure Notebooks, which is a free service for everyone who wants to run their own codes on Jupyter Notebooks. For data scientists, Jupyter Notebooks are very, very popular tools, and is, of course, hosted on Azure. For this specific demo, I already created my project here that is called Automated Machine Learning Microsoft Build. And this is a public project because I made it public because I want all of you after this talk to go there, try the code, and of course, let me know what you think, if you have additional questions. I really want to, to get your opinion on this. So, without automated machine learning, as you can see, there is a folder for this. My life as a data scientist was very, very painful. I was spending several weeks getting the data, so doing all the data ingestions, doing all the data cleaning, and then I was preparing my data, and I was moving to the model selection phase. And the model selection is like something that you do as a data scientist. You have some knowledge, but the answer to the question, which model, which algorithm should I use, is always, it depends. It depends on the type of data that you have. It depends on the type of business problems that you want to solve. It depends a lot on how much time you have as a data scientist. So I was manually building all these different models, many different notebooks, and then I was trying to do some hyperparameter tuning to eventually improve my models. But again, it was a very iterating, time-consuming process. And just to give you an idea, this is one notebook, and this notebook is just for data preparation. So after that, I ingest my energy data. I was doing some data cleaning because sometimes CS can be missing. There are also some outliers. Then I was moving to the exploration of the data. Again, I was doing some visualization to understand also the correlation between, for example, here, demand and temperature. I was also using autocorrelation plot to get a better idea of the relationship between these two variables. And then I was starting with all the feature engineering process that Eric was referring to. Here, time series data is a very, very interesting type of data because it must be reframed as a supervised learning data set before we can actually start using machine learning. And data engineering, feature engineering is something that can be very helpful. Like you can create data time features, lag features, window features. These are summary of values of a fixed window of prior timestamps. So again, here I was just creating all these manually. As you can see, the hour, month, day of the week. And again, this was just for data preparation and data cleaning. And then if you go back, you can see that before automated machine learning, I had to create many different notebooks with a lot of different models, linear regression, read regression, that is a technique for multiple data regression that suffer of multiple linearity, for example. And then I was trying multi-layer perception, that is a different type of feed-forward neural networks, decision tree, and then I was evaluating all of them. So as you can see, everything was pretty complicated. This is my life as a data scientist. It's painful. But again, I was enjoying it. It was taking a lot of time. But then, of course, I have to say, AutoML arrived in my life. And I have to say, my life really changed. Because as you can see, instead of having 20 different notebooks, and again, instead of iterating all the time, testing different type of models and doing different type of hyperparameter tuning, I'm actually right now just focus on data cleaning, data preparation. That for sure, a little bit of data exploration is always very helpful. But then in just a few hours, a few days if you want, I'm able to get a good model, a good understanding of what my data set needs to get a very nice accuracy. And let me show you how this works, really. So here in this notebook, I'm doing everything. So I'm, first of all, creating an experiment in my existing workspace that I was sharing with you earlier at the beginning of my presentation. And then after this, I get also a snapshot of the workspace, so my subscription ID. And then immediately after this, I can start ingesting my data. And again, for this specific use case, we also use open dataset, so specifically the weather data from Azure Open Dataset. So as you can see, we have many more data and different type of features. Then immediately, I can split my data into training and testing, and I can start the initiation of AutoML configuration, and this is the core part of automated machine learning. So here, what we are trying to do is just tell AutoML that we are doing a forecasting. So our data is a time series in a time series format, and we want to do forecasting. So as you can see, I just need to specify the forecasting task here. Then you can also define the primary metric that you want AutoML to use to evaluate your data, the different runs and the different models that is going to try for you. The number of iteration, let's say that you don't have too much time, so you want to pick 5. If you have, of course, more time, 10. Whatever number of iteration you prefer for your specific use case, the iteration timeout in terms of minutes, X, Y, and also the number of cross validation. So what I really like and what I really love of automated machine learning is that I can still, as a data scientist, have a total control, transparency, and visibility on what it's doing. So AutoML is not a black box at all, because as a data scientist, I can really see what it's doing. And most importantly, after the auto config file, I'm here, and immediately I can see all the results, all based on, again, my data set, my use case, and also get a better understanding on the type of metric that I'm using and how this is performing. Again, this is very easy. I'm actually running these locally on my laptop. If you want, you can also create and attach an existing computer resource on that. And then after this, you can immediately ask AutoML, okay, what's the best model for you? You just need to do it with the best run again, and is going to output the best model for you. You can also view the engineer names for futurized data. Again, this is one of the best parts, I have to say, as a data scientist, because we have this time series featurization. So as you can see, we have a number of feature engineerings that were created for us, and it's just very easy to look at the list of those additional features. Then, of course, you want to test your best model, and finally, after this, you are ready for the deployment part. So the deployment part here. Actually, here I was also using the MAPE, that is mean absolute percentage error. This is a metric that is popular among data scientists who are building time series forecasting. And as you can see, our model is 95% accurate, which is pretty good. I'm satisfied. So at this point, I'm ready for the deployment part. And the deployment part is very easy in Azure Machine Learning Service, because the only thing that you need to do is to write the init and the run function. So the init function here, usually, as you can see, loads the model into a global object, and then the run function here in this part, this function uses the model to predict a value, so a future value. Again, after this, we are ready to deploy the model on ACI. For this specific use case, we use ACI, that is the Azure Container Instance. So as you can see, I showed just some parts of my notebooks, but in one single notebook, I was able to do a lot of things that before I had to manually do. And second, I had to build a lot of different notebooks, models, and just manually compare all the results and evaluate all my models. So this was pretty easy. And then as a data scientist, most of the time, I want to do two things. So first of all, I want to see my model deployed. And of course, if you go back to the Azure portal, you are going to see here under experiments, I have the experiments that I created for that specific use case that is called AutoML Energy Demand Forecasting. Here, I can also look at the different models that I deployed, and this is exactly the model that I deployed. So it's easy immediately, as soon as you deploy your model from the Azure notebooks, you can immediately access it here from the Azure portal. And then the second thing that I want to do after the deployment of my model is also, I want to share my results. I want other people in my team to be able to consume my model in an easy way. And most of the time, I work with the customers, and they want just to see the results in an Excel spreadsheet. They don't want anything too complicated. And so what is nice is that when you deployed your model in Azure notebooks, in our use case, we use ACI. This gives you also a URI that you can use here, as you can see. And so let's say that we want to predict the first 24 hours of energy consumption for the first day of February 2017. So what you can do is just select a specific cell. So in this case, we are looking at the first 24 hours. And you are going just to use, again, the URI that you created in your notebook. And you can just use that formula. And immediately, this is going to show you the results from your model, which is very nice because you want product managers, you want other data scientists or like business experts just to easily look at the results from your model. And most of the time, I have to say Excel is the best option that we have to communicate the results from our machine learning models. So thank you very much. I hope that you enjoyed this demo. Again, this is a public project, so I really invite you to try it out and let me know if you have any question. And now back to Krishna. Thank you.
Thank you, Francesca. As you can see, with just a couple of steps, you can build a machine learning model. All you need to do is configure the AutoML object, and then ask AutoML to build a bunch of models for you and give a high-quality model. With few more steps, you can actually take the model that you built and deploy it and get a web service endpoint, a REST endpoint that you can use for consumption, for prediction, right? Now, what if I'm not a Python developer or Python data scientist, right? Is there an easy way to do it? I'll show you how I can use the same exact data set that Francesca used and build a model without writing a single line of code. Let me find my screen. And so this is the portal, Azure portal, right? And this is, I'm in my Azure Machine Learning workspace. See a button here, or menu here called Automated Machine Learning. So I'll click on Automated Machine Learning. And here, I'll go and say, create an experiment. And then I'm just going to give a name. Let's say build demo, and choose a compute. Actually, I'm going to try creating a new compute. So in here, I'm actually building an Azure Machine Learning compute cluster. And let me just give a name. And I have several options in terms of the virtual machine that I can choose. Okay? I'm just going to pick, depending on your data size, if you have a large data, you probably want to choose a machine that has a lot of memory, right? I'm going to randomly pick this one. Then click on additional settings. We actually manage the compute cluster for you, and it has the auto scaling functionality. So I set the minimum nodes to 0, and the maximum nodes actually the defaults were 0, and the maximum nodes are 6. What 0 means is when I'm not running any jobs on my compute cluster, it actually brings down all the machines. And when I kick off a bunch of jobs, it actually scales out the number of machines and starts processing the jobs. Now, because this takes a few minutes because it needs to set up the nodes, but I have an existing cluster that I already set up. So I'm just going to use this, and you can build a GPU cluster also if you have deep learning model, right? Then click next. Now, I have a blob storage container where I loaded this data. It's the same exact data that you have seen earlier in the notebook. It has the timestamp. So these are the hourly values of the energy demand, historical demand, the actual demand value, and joined with a bunch of weather data like temperature and precipitation. Right? Then I go here, and this is a forecasting problem because I'm trying to predict how the forecasting is going to be in the next future, in next 24 hours, next week, or next month. So I select forecasting. And then my target column, which the column that I'm working to predict, is demand. Right? So I select demand, a bunch of optional values, and the forecasting horizon is how far in the future that I would like to run predictions are. So I'm going to say 168 hours, which is about a week. And then I can even go into advanced settings. So these are a bunch of default settings. So if you're just starting, or if you're new to the data science, or you can just start the experiment. I just want to show you what advanced settings look like. These are very similar to what you have seen in the notebook, like how many iterations I want, how many concurrent iterations I want. And you can even blacklist some of the machine learning algorithms if you know that a particular set of algorithms that do not work for your data set, saving the compute and the experiment time. Right? So I'm just going to leave it with the default values, and then I'll just start. What it does is basically submitting the experiment to AutoML on the compute cluster that I have set it up. Right? So this will take a few minutes. Let me show you the one that I finished earlier this morning, actually yesterday. So I ran with 25 different iterations. And as you can see, all these blue dots are the actual models that AutoML built. It gives you a nice little graph that shows how the model performance is improving. In this case, the model metric that I was trying to optimize is the root mean square error. And the lower the value, the better the model is. Right? So it's done 25 iterations, and the last one happened to be the best model. And I can actually see what all these models are in a nice little leaderboard fashion. So the iteration number 25 or 24 is the best model. The next best is 10. And if I click on this, my particular model, it will actually show me a whole bunch of visualization graphs and charts that data scientists usually take time to write Python code. Right? So you get all these charts, and also you get a lot of metrics for this particular model. I mentioned that we use the root mean square error, but typically data scientists want to evaluate a whole bunch of other metrics to make trade-offs on which model to use, or if they want to further tweak it. Right? So it gives you a lot of flexibility and control on the models that you built, right? How cool is that? You know, you just did not write any line of code, but able to build a model just with a few clicks. Right? Once I have the model, I can actually go to my models here, and I can take the model and use the deployments here. I can make a container of the model into a Docker container image and deploy the model and get a web service endpoint, all through this UI. Right? So we have few options. One is if you're Python, if you're comfortable with Python and you like code, you can use the notebooks or any IDEs that you're familiar with, PyCharm or VS Code, right, and build machine learning models. You can also use UI to build machine learning models with AutoML. Now, let me have Dean on stage and have him share his experience on how he benefited from AutoML in his organization. Thank you.
Put it back into PowerPoint.
Yeah.
Hi, everyone. Thanks for having me today. So I'm Dean Riddleston. I'm a senior data scientist at Walgreens-Boots Alliance. I'm going to take the next few minutes just to talk about a project that we've been running with Microsoft over the last few months that was looking at how we can take some of our machine learning workloads and sort of get them onto the cloud and use technology like AutoML to see if those workflows could be improved. So a little bit about Walgreens-Boots Alliance, then we've got some stats on the screen. I'm sure a lot of people in the room are familiar with Walgreens. You might be less familiar with Boots, our largest retail organization in the UK. But we actually have a presence in more than 25 countries globally. We're a huge business. We're a very complex business. We employ over 415,000 people. We're the largest retail, pharmacy, health, and daily living destination in the US and the UK. We're also one of the world's largest purchasers of prescription drugs, as well as other health, beauty, and well-being products. And we have a colossal pharmaceutical wholesale and distribution network with over 390 distribution centers in more than 20 countries globally. So within WBA, we have Boots UK, and this is where I'm predominantly focused, and this is where we focus the AutoML application with Microsoft. So in the UK, we have close to 2,500 stores. We have 618 opticians' practices. And a fun fact is that 90% of the UK population are actually within 10 minutes of a Boots UK store. So we'll run a lot of in-store events for our customers as well. We have more than 14 million Boots Advantage Card members. So if you're not familiar with the Advantage Card, it's very similar to the Balance Rewards Card in the US, albeit with a few slight differences. And it's the data generated from the Advantage Card members that we used for this machine learning application. We offer over 33,000 products on Boots.com, our e-commerce platform. And interestingly, around 70% of these .com orders are actually collected in store. So we have a very complicated logistics and warehousing operation that supports all of this. And at Boots, we actually make the promise to the customer that if they order something online, they can collect it in store the next day. So there's a lot that goes into delivering that promise. So in terms of data science at Walgreens-Boots Alliance, what is it that we're actually focused on? Well, first and foremost, marketing campaign optimization. These are essentially the machine learning models that drive our campaign and our marketing activity. We spend so much time focusing on this because it's really important to us that we demonstrate that we understand our customers. And it's here that we apply the machine learning that sort of takes customer attributes, customer preference data, and make sure that we send them timely and relevant offers and marketing communications. And it's this application that we concentrated on to move to Azure and actually apply AutoML to this specific problem. We also maintain recommendation engines for our e-commerce platforms in the US and the UK. We do a lot of A/B testing, and in more complex scenarios, we will look at incremental and counterfactual estimation. This is really kind of understanding when we apply ML and algorithmic targeting to some of our communications and offers, where is it working well and where does it need further improvement? We do a lot of text mining as well and natural language processing. Interestingly, a lot of the projects that are coming into my area of the business at the moment are focused around NLP. We also manage customer segmentations for our internal partners. We dabble with geospatial analytics, although we have a very, very good dedicated geospatial team based in the UK. We do a lot of data visualization. We are a team of data scientists, after all, and we do a lot of proof of concept type activity and assessments of new technology. And in terms of the sort of technologies that we're interested in, I've listed those on the right-hand side there. So primarily Microsoft Azure, our business is moving to the cloud. But we're interested in open source programming frameworks and languages, so Python, R, popular machine learning frameworks like TensorFlow, Keras. We use a lot of XGBoost and LightGBM. It's LightGBM that sort of powers a lot of our predictive modeling at the moment. So the scenario that we worked with Krishna's team on was campaign optimization. So at the moment in the UK, we have over 150 probability of purchase models, and these are driving over 1,500 marketing campaigns per year at the moment, but both of these figures are increasing. We're doing more campaigns and we're having more requests for modeling. As I mentioned, we use these models to kind of understand customer preferences and calculate customer affinities for particular items, particular ranges or brands. And then we can use that information to make sure that we're sending the right offers to the right customers at the right time. We can combine the outputs of these models with business logic, and that's what we then use to derive an audience for each marketing campaign. Each model, though, is very compute intensive. We use a lot of data. The complexity of the task is high. We use many hundreds of features, and we also have to retrain these models on a daily basis, so it's a big computational workload. We have to retrain them on a daily basis, otherwise we see model drift. We use a lot of temporal features, so we have to keep the models fresh. It's a big effort, but it's worth it, because campaigns that are modeled in this way have been proven in our business to deliver over 3 times the incremental sales when we compare it to campaigns that use just business logic alone. So it's a very powerful system and one that we really want to migrate. But our existing solution is very simple. We have a data warehouse that produces all of the aggregates. It also stores all the data that we need for this type of workload. And we have a modeling server. We have a number of modeling servers where we actually do the machine learning. Unfortunately, we don't have any ability to scale either of these compute resources. They're on-premise, they're fixed, and given that the campaign activity is increasing and the number of models that we have to run are increasing, that's not future-proof. So within the data warehouse, when we're producing these large aggregations of data that are then being fed over into our modeling environment, we can see bottlenecks, and bottlenecks obviously cause problems. It means that some of our machine learning workloads can't run. The networking between these environments slows us down. We're reading and writing with ODBC connections, and that's not ideal. The models that we have at the moment, they train in sequence. We can't parallelize 150 models to run at once, so they're running one after another. And what that means is that we can't do any sort of hyperparameter optimization because it's just so compute intensive. We can't be doing a brute force grid search on every single model as it retrains because the whole system then takes too long to run. So the way we get around that is we used a fixed set of model hyperparameters, a global set of hyperparameters that were the best fit for the suite of models that we had running, for the 150 that we had running. What this means is that there will be models in there that are not receiving the best hyperparameter combinations. They're just receiving this global set that we know is roughly what we need, but not as fine-tuned as we could be. So we've moved from that very simple architecture to this high-level architecture. So essentially, we're ingesting data with Data Factory. We're moving that into a storage area. So we're using blob storage here, and we have a sort of data aggregation engine that's taken on the workload that we would typically do on our on-premise data warehouse. And for that, we've used Azure Databricks. We can then pump that sort of cleaned, featureized data back down into blob, and then ingest that into our machine learning environment. So here we're running Azure Machine Learning Services, and within there, we're running AutoML. And it's the AutoML part that's really important, because what that's allowing us to do now is tune our hyperparameters on a per model basis. And it's also allowing us to distribute the training of these models across a very large compute cluster that spins up and down automatically. So we can get to a point now where each of these 150 models is doing hyperparameter optimization and training on its own dedicated resource. So basically a small DSVM. Within that same environment, we can then produce scores for these models and push that out to a serving layer. There we would typically use a SQL database, and that connects to other applications downstream. So if our analysts and our marketeers want to go and build their audiences, they would typically retrieve the information from that environment. So what have we found then? Well, improved productivity was the first thing that we noticed. And this is really important because with AutoML, we were able to find really good models really quickly. It wasn't taking hours or days of data scientists' time testing all the different algorithms, testing different combinations of hyperparameters, doing all the grid search stuff. We just didn't have to do that. And we actually knew that some of the algorithms in AutoML were better suited to our data already, so we were able to whitelist those, as we saw earlier. So it saves us time selecting and tuning the models, but we were also able to log all of the results of each experiment into the Azure ML Workspace, and that's really good. That's given us visibility of what we were doing, when we were doing it, and what the results were, and you can easily lose track of that in our old system. And what's really encouraging is that we've seen similar AUC metrics when we compare to our baseline models that we have in production at the moment. But in some cases, AutoML is exceeding the performance of those models, mainly due to the hyperparameter optimization, which is just really exciting to see. Of course, we were able to scale the solution. This is something that we absolutely couldn't do in our old architecture, so it's great, and that's allowed us to really scale it out, run everything in parallel. Obviously, that enormously decreases the runtime, and it takes a huge amount of load off of our existing on-premise resources, so it's been really good to be able to scale out to the cloud. And the third point I'd raise is on democratization. So what I mean by this is it's allowed less experienced team members, perhaps analysts who want to get into the data science space, it's allowed them to build good models efficiently and quickly. And that means that someone who's perhaps not got the experience of data scientists can build a production-ready model quite quickly. So looking ahead, where are we going with this? Well, we're going to continue to migrate all of our campaign optimization modeling to machine learning services, and we're going to continue to use AutoML to identify the best algorithms, but also the best hyperparameter sets for each of the models. That saves us a lot of time and effort. We're going to use low-priority Azure ML compute to try and save cost, and we're going to look at in-database model execution as well. We're not sure if this is the right thing for our current use case currently, but we're going to take a look at it. And we're also going to build out modeling pipelines so that we can actually better manage the model lifecycle and the model build, test, and score process. And we're going to integrate with CI/CD for continuous training and deployment. So exciting times ahead, but for now, I'll say thank you and hand you back over to Krishna.
Thank you, Dean. So we truly want to democratize machine learning by enabling the users where they are and build machine learning solutions. We have built, we powered some of our products with AutoML. So let me walk you through a couple of integrations that we did. Power BI, if you're a Power BI user and work with a lot of data, you can actually build machine learning models inside the Power BI. So this service has been in public preview for a few months now. We've seen users building models, for example, churn prediction, sales forecasting, and things of that nature. Not only they can build the models, for example, if they build a model for churn prediction, they can actually apply it inside Power BI and use that for predictions, right? So they can find out why, the main reasons of the churn, right, with their customers, and who is likely to churn, and take corrective actions to actually reduce the churn. SQL Server, if you're an app developer, the SQL Server integration is very interesting. I'll go into a little more detail on the SQL Server. And if you're a .NET developer, not a Python developer, but .NET developer, you can use AutoML now in Visual Studio as well as VS Code. That might be interesting to you. So with SQL Server, if you can build a model using Azure Machine Learning AutoML, just like what you have seen, and deploy it inside SQL Server and use it for prediction with a stored proc. Just pass the data that you want to predict in a stored procedure, and then the stored procedure, when you execute the stored procedure, it gives you back the predictions. Think of you have a personalization app or a web service that you want to offer to your users. And if you have your app, most likely your data is in SQL Server, right? And you have an entire application. You can use your app to basically run predictions of personalization on the model that you have deployed in SQL Server and render that in your web service, right? Very powerful. Now, you can also, instead of using Azure Machine Learning and AutoML to train the model, you can actually train the model inside the SQL Server itself, right? So it's very similar to what you have seen. You configure with, for example, the task, iterations, the experiment name, and the primary metric you are working towards optimize, and run the training job inside the SQL Server. So you don't need to move the data. Very powerful. Now, another integration that, by the way, you can find more information on a blog posting that we posted here on actually how to use this thing. Other integration we worked on is the Visual Studio. So if you are a .NET developer, the options for you are learn Python and machine learning. So the barrier is pretty high, right? No more. We are bringing the same AutoML technology for .NET. So you can use Visual Studio and write in .NET code, the C# code, a machine learning model, right? So exactly works very similar to Python, where you create an experiment with a bunch of settings, and you run the experiment. And AutoML, behind the scenes, builds a bunch of models and gives you the best model. You can also use CLI to do the same thing. And with CLI, AutoML will not only give you a best model, it will also generate the code for you that you can use further, right? You take the model that you built using this AutoML in your .NET code and load it into your app and use that for prediction, right? No need to learn Python, and with very simple machine learning steps, you can build this. How many of you are .NET developers? Most of you. So this would be very useful. And the other thing, Eric mentioned this earlier, you can build models in Python using UI and then convert them into Onyx. AutoML actually gives you Onyx model that you can take and load it into your C# app also. 2 ways to do this. There is a session that goes into a lot more details. There are a lot more capabilities that I'm not able to show here. At 4:30, please do check out. The last one is, you've seen Microsoft products, how AutoML is powering. We are integrating with non-Microsoft products too, not limited to Microsoft. Alteryx is one of a popular data analyst tool. Within Alteryx Designer Studio, basically configure machine learning just like you've seen umpteen number of times earlier, and kick off training inside the Alteryx. And then take the model that you built and run it, use it for scoring and prediction. And you can use the model that is built in here in Alteryx and actually deploy it in AKS also for prediction. There's a blog post on how you can do this with Alteryx. So to summarize, AutoML, I have heard again and again from many of our users, hey, I wish I have this AutoML when I started building the machine learning models, because this is really making my life easy, right? So democratize by enabling all the users into not just AutoML, but lots of other products, and use the tools that you are already familiar with to build machine learning models. Improve the productivity by eliminating a lot of tedious tasks, and you can actually, because of the AutoML, you can actually scale to build many, many, many models. Here are some of the resources that you can go and check out, and thank you for staying here, other sessions, and please do fill out the evaluation. We ran out of time, but we are available here for questions offline, as well as we have a booth in the expo. Please go check out if you have further questions. Thank you.